Okay, so today we're going to talk about how to find solutions to a particular quadratic formula. Now, when we talk about solutions, what we're saying here is on an XY graph, the solutions are where the parabola actually crosses the x-axis. Okay, those are the solutions, the zeros, sometimes they're called. And quite honestly, the easiest way to solve a quadratic, or to find the solutions, to find the zeros, is just to factor it. Okay, so if we look at this quadratic here that we have up above, if we factor this, and find the solutions this way by just setting it equal to 0, that's the easiest way to find the solutions. But the question becomes, well, how do we find the solutions? How do we find these particular values if the quadratic doesn't factor like this? If it doesn't factor, how do we find the solutions? We talked a little bit about that with completing the square. But how do we go about finding the solutions if it doesn't factor? So what I want you to do is look on the handout that you've been given and notice that we have a quadratic in what's called standard form. Okay, this is standard form right here, where the ax squared plus bx plus c, that's the standard form. And let's say, for example, that this quadratic does not factor. How do we find the solutions? And the answer is to use this formula right here. Now, where does this formula come from? How do we use it? Are all good questions. And when I come back next week, I'm going to show you where this formula comes from. It actually comes from completing the square, but it's a little hard to do on yourself. But if you want to try it, you can. So let's take the first example here on your paper that you've got, example 1, and it says 2x squared plus x equals 5. Okay? The first thing that I'm going to do with this quadratic, sorry, this 5, right? It's a 5. This quadratic is not in standard form. If you'll notice up here above, in the quadratic that I'm underlining right here, we're equal to 0. We want to zero this thing out. Okay, in other words, that's what we want to say. So what I'm going to do is I'm going to subtract 5 so that the equation is equal to 0. Now, if you want, you can try to factor this thing right here, but it's not going to factor. Okay, so how can we find the solutions to this particular quadratic? The way that we're going to do that is we're first going to identify the a and the b and the c values. Okay? The a value is always the value, the coefficient, I should say, of the x squared. The b value is always the coefficient of the x, and then the c value is always the constant. Okay, and the thing you have to be careful here is you have to be careful to carry any sign with the number. So in this case, we have to make sure that c is equal to -5. All right, so in doing that, what we're going to be able to do now is to take these three values and plug them into the quadratic formula. And if you look on your paper, I've sort of already done that for you. But I'm going to try to squeeze all this in on this one slide. So I'm going to do my best here. So I hope that it works out. So just sort of bear with me here if it gets a little tight. Okay, I'm going to draw a line, sort of separate what I'm doing. Okay, so first notice here, it's -b. So my b is 1. So when I put this in the formula, I'm going to have -1 plus or minus. Okay, then I'm going to have the square root. B squared is just going to be 1 minus 4 times a, and then times the c, which is that -5, and I'm trying to, there we go. And all of this is going to be over 2 times a. So all I've done is I've just taken these three numbers right here and I put them into their various letter values into this formula. And I'm going to simplify this best I can. This particular expression, as you can see on your paper, is going to simplify to -1 plus or minus the square root of 41 over 4. And this is actually producing two solutions. Why is it two solutions? Because of the plus or minus here in the middle. Okay, it's the same thing as -1 plus root 41 over 4. Sorry about that. And -1 minus root 41 over 4. Okay? So there's two solutions. And again, these two particular values are where the parabola is going to cross the x-axis. And if you look on your notes, the A value was a +2, which means the parabola is going to open up. It's going to look like a smiley face. Okay? So we're gonna look at another example here. Okay, so if you turn over to the page, we're going to be on example 2. Okay, and we're dealing with the equation x squared minus x equals 5x minus 9. Okay, so again, the first thing I want to do is to put this into standard mode. Okay, sometimes it's called zeroing out the equation, but basically that means getting all of this stuff here over to this side. So if I subtract 5x with the minus x that's already here, I'm going to have minus 6x. And then if I add 9 over here, I'm going to have plus 9 equals 0. All right, so the first thing to do now is to label the A, the B, and the C values in this particular quadratic. Well, A is the coefficient of x squared, so that's 1. B is the coefficient of x, and remember we have to carry the sign, so -6. C is just the constant value, and that's going to be a +9. So my A, B, and C values are listed, and now what I'm going to do is I'm going to put these into the quadratic formula. Okay, so without writing it again on the slide, please refer to your paper so that you can kind of follow along here. All right, so the biggest thing that we need to focus on is that the first letter in our quadratic formula is -b. But b is already negative. So -6 is actually going to be a +6. Plus or minus the square root of b squared. Well, -6 squared is 36. Minus 4 times A times C, all over 2A. Okay? So, if we look at this, we've got 6 plus or minus the square root of 36 minus, 4 times 1 times 9 is also 36. So really what we have is 6 plus or minus the square root of 0 over 2. Well, the square root of 0 is just 0. So 6 plus or minus 0 is just 6, and 6 divided by 2 is 3. So this particular quadratic only has one solution. What does that mean, one solution? That means that on a graph, the parabola is actually, the vertex, I should say, of the parabola just sort of sits on the x-axis. It doesn't actually cross at two different places like the other examples we've done, but just at that one particular place. Okay, so that's sort of the idea of this particular equation. Okay, so we're going to do one more, and then I think I'm going to have to start a new video for you to watch, because I think the videos can only be 15 minutes on YouTube. So we're going to do one more equation, and I'm going to try to do this one a little quicker to make sure that I have enough time. Okay, but let's start a new page here. Example 3. We've got -x squared plus 2x equals 2. Again, I want to put this in standard form, which means I want to subtract 2 over here, zeroing out the equation. I'm going to label my a value, my b value, and my c value. -1. B is going to be 2. C is just a constant value, -2. And I'm going to take these three values and plug them into the quadratic formula. And again, all this is on your paper, so hopefully you can just follow along here. Okay, so we're going to have -b plus or minus the square root of b squared. So 2 squared is going to be 4, minus 4 times a times c. I'm sorry, my handwriting is terrible here. And this is all over 2a, which is just 2 times -1. So the thing to look at here is under the radical you're going to have 4 times. -4 times -1 is +4 here. +4 times -2 is -8. So we're going to have 4 minus 8 under the radical all over -2. And then this is going to be -2 plus or minus the square root of -4 over -2. Well, what do we remember about square rooting a negative number? Technically you can't do that, but we've talked about imaginary numbers, and what we've talked about is that when you have -2 plus or minus the square root of -4 over -2. So when you have a negative number, we can introduce complex values. So this becomes the square root of, -2 plus or minus. The square root of 4 would normally just be 2. But since we're square rooting a -4, this actually becomes 2i all over -2. And remember, I've stressed to you how to cancel things out, how to factor things out. Up in the top here, both of these have a factor of 2. So I can factor a 2 out. And on the inside, I'll have -1 plus or minus 1i all over -2. And then these 2's can kind of just cross out here. Okay? So you'll sort of be left with -1 plus or minus I over -1. And then you can multiply the negatives out, and so you can kind of just get 1 plus or minus I as your final answer. So what does it mean to have complex roots on a graph? On a graph with complex roots, notice that the leading coefficient of example 3 was a -1. The a value was a -1. That means the parabola opens down. So if the parabola opens down and we have complex roots, that means that the parabola doesn't actually cross the x-axis. The vertex, wherever it may be, okay, maybe it's over here, maybe it's over here, okay, but the parabola basically just kind of floats below the x-axis. It never actually crosses. It never actually crosses the x-axis, making those roots imaginary. Okay? And so we know the parabola opens down because a is negative. Okay? If the a was positive and you had imaginary roots, the parabola would sit above the x-axis. It would sort of float up here above the x-axis. Okay? So that's going to conclude our first video. There's going to be 2 videos. It's going to talk about, the next one's going to talk about the discriminant. But this is where we're going to end here. And so hopefully we can queue up the second video in just a minute. Okay? See you in a second.